Yeah.
Didn't do the little notifications saying that you're recording. Okay,
Has
then when you're
anybody
sharing the
done this
screen,
before? Have y'all taken this before? Since everybody's first time, really?
I mean, it has a little notification. So maybe it just does it, maybe it just does it to the people on Zoom. Here we go.
Okay, so we're on.
We're ready to go, yes. Go ahead and tell us a little bit about yourself.
So I will.
and We'll get started.
Oh, that's
Thank you so
cool.
much.
Yeah.
Oh, and I don't know if you ever get to feel like-
I'll let them, if the glare is too much on the screen, let me know. They can adjust the lighting, but if you're joining us on Zoom, welcome. I'm Derrick Ginter. I've been chasing weather for, gosh, 30-something years. And I've been working for Ron Roberts for almost that long, 25, 28 years, something like that. And he's got it one day, we've got Derrick Ginter on the phone and he's looking at this cloud. DG, tell us what you're seeing. And it was like, DG? I like it. So, in broadcast, if you can do things, be brief and brevity and all of that. So suddenly I got named DG. My church was doing an emergency preparedness fair and I brought Ron out and we had the chase vehicle and we were giving away, rain gauges and stuff. And my mom came up to Ron and said, I'll have you know, I named my son Derrick and you're calling. She just gave him what for?
Good for her.
Exactly. Right. So I go by DG. I go by, I don't care what you call me as long as you don't call me late for dinner. Is that the saying? Anyway, welcome to watching the wacky weather of West Texas. I've got a lot of stuff. I'll try to get through as much of as I can because all the good stuff's at the end, the tornado videos and all of that fun stuff. So I'll try to get through this. I think the class we're going to try to cover some weather, basic weather, what we look at in terms of storms and things. But first, an introduction. So I'm originally from Amarillo, but my family moved here in '77 and we've been here ever since. So I graduated from Coronado High School here in Lubbock. I did go to Texas Tech. I've got the ID badges to prove it. I hated school. I didn't do well and I ended up dropping out. And then I went to work for the police department at the Texas Tech Health Sciences Center. I was a police dispatcher and 911 operator for almost 5 years. And the one thing that job taught me was get your butt back into school and finish. So I started tech in the summer of '87 and I finally graduated with my bachelor's in '96. And then I went back for my master's. One of the things that I've got like 35 years here at Texas Tech and boy, I feel it. What most people know me from is my work in public radio. I managed the public radio station here at Texas Tech when it was still called KOHM. In fact, their studios are upstairs. They're up here on the 6th floor on the east end of the building. I had the corner office. I overlooked downtown and I missed that office. But I was in radio. Radio is kind of my thing. So I was a police dispatcher. I went to work for Clive Kinghorn in the late '90s. And I started working at KOHM. And when he retired in 2001, he picked me as his successor. I don't know what he was thinking. But I managed the NPR classical music FM here in Lubbock for 10 years. I was also working part-time in commercial radio across town, just doing a lot of odd jobs. But I finally had to give that up in 2011. Yeah, 2011. And in 2012, I went to work on main campus over the student radio station, which is where I am now. So I'm over the College of Media and Communication at Texas Tech, and radio is my thing. So my day job, when I'm not chasing weather, is I'm in broadcast. Broadcast is my gig. So I also, on the side, read names at commencement. So I don't know how I got into that. It's a long story, but I've been doing that almost as long as I've been chasing weather. So whenever we have commencement here at Texas Tech, I read names for the Rawls College of Business. And that's interesting. I always tell the students, don't worry if I mispronounce your name. Remember, it was professionally mispronounced. So, but that's a little bit about me. Really, what we're here for is to talk about storm chasing. And like I said, I've been with KAMC and Ron Roberts for 25 plus years. This is an old picture of the old Storm Team weather lab that we had at the KAMC-TV studios. It was an elegant TV set, let me tell you. It was all of the technology and camera, the monitors and displays and all of that. If I turn this, I don't want to lose the Zoom people. Hopefully I can speak loud enough. So there I am, and there's my wife. This was the guy in Baton Rouge, Kevin, I can't remember his last name. Of course, Ron Roberts, I'm forgetting names. Anyway, Al Harden, my mentor, is here in the back. This is Matt Hines. He's a chief meteorologist in Waco. Almost all these people are gone. So they're in other places. They're still with us. They're just to be careful how I say things. But David Young, the guy in the bottom right in the red tie, he was chief in Lansing, Michigan. Almost all of these folks have gone on to, other TV markets and have done quite well. But I love this old picture because this was the weather lab, and we were dominating the Lubbock market in terms of severe weather coverage based on just this set alone. Now, if you didn't already know, everything in television is for the visual. It's made to look like it's fancy, super, or whatever. This set did not survive the transition to digital when TV went digital to HD because it was a piece of junk. The old analog cameras, it looked fine, but when you put HD on it, it was like, oh man, look at the carpet, the coffee stains in the carpet, it was just bad. But this is what we had to work with. This was late 90s through early 2000s. And I think about 2012, 13, 14, they finally had to get rid of this set. Now 28 and 13 merged, and that's where the Texas size logo comes from. Those were dark days. But anyway, we're going to talk about my exploits in the severe weather realm. So that's a little bit about me. Of course, I worked for this guy, Ron Roberts, and this is our chase vehicle that we had. I'm in the background there. The things you can do with graphics and computers, because it was bright, sunshiny day when we took these pictures over in East Lubbock. And of course, the joke is Ron would always, Ron is notorious for kind of hyping stuff up. And so his nickname is Run for the Hills Ron. Oh, there's a cloud in Lubbock, run for the hills Ron. So when we were taking these pictures, I said, Ron, just follow me on this. And I started running up the hill and he got the joke, Run for the Hills DG. So anyway, so one of the questions I get asked most often is, what do I drive when I'm out chasing the weather? And thank you for asking. This was the strike unit. This was the old paint scheme. Actually, it's not a paint scheme. It's a vinyl wrap that they shrink wrap to the vehicle. Okay, this old Hummer. And pay attention to the words under the word strike. I don't know if you can make that out. Does the name Rager Dykes ring a bell? Yeah, for those of you that don't know, Bart Rager had a number of car dealerships here in Lubbock, and it didn't end well. But he provided us this chase vehicle, this Hummer, and it looks impressive, right? It's got the TV. It looks really cool. And you would think that this would be the perfect chase vehicle. It wasn't. It drove like a dog. I think it had a 4-cylinder or something. It was just chronically underpowered. Had a great weather instrument package on the roof. And whenever I wasn't using it for weather, the news department would use it for the reporters. They would take it out and, drive around and use it for whatever. And I'm here to tell you, despite all of the severe weather and big hail that I got this vehicle into, I even rolled it into a ditch once. That was nothing compared to the damage and destruction that the news crew did to this car. Okay. One poor girl, one reporter, she drove it under some low-hanging trees, took the weather package off the top of it. There's $1,200 gone like that. Didn't get it replaced for some reason. But this was the vehicle that I used most of the time when I was chasing. Here's the second iteration of it. They put a brand new vinyl wrap on it. So this was the new paint scheme. And the thing that I hated most about this car was the windows. Notice the passenger window had the vinyl covering the window. That was a really big pain. And we got that fixed the second go around. But this car got repossessed. So when Bart Rager and his company went belly up and he was in trouble, and he's serving time now, we actually had a GPS tracker in this car so they could follow me on the map. And I would always disconnect it because I didn't want him to know how fast I was going. Ron was notorious. I'd be down in Lamesa or somewhere south of Lubbock. I need you in Plainview. Oh, okay. When? Now? Okay. I'd floor it, So yeah, I was kind of a speed demon in this car. So I would always take the GPS tracker out, but they left the GPS tracker in on the day it was repossessed, and they actually tracked it. And it ended up in a parking lot in the south side of town for weeks. But yeah, we lost this car because of Rager Dykes. So my tried and true vehicle, my favorite chase vehicle, was my personal car. This old beat up GMC Yukon, I think it was a 2008 model. And yes, the peeling paint on the hood is from the hail damage. I mean, I can't tell you how many windshields I replaced in this car. And people are like, well, why would you take your car out? Well, several reasons. First of all, I know how it drives. I know how it handles. This is my daily driver, right? I don't have this car anymore, by the way, but all my radio gear and the electronics that I would take, I had it all wired. And so everything was ready to go. When I was driving the Hummer, I'd have to take all that out of my car and put it into the Hummer. It was always a big pain. And yeah, the damage to my car was personal. I think I made my auto insurance guy really mad because he wanted to charge me higher rates, because I was involved in a highly risky business, until I explained to him, well, I'm out there telling people to put their cars in the garage because the big hail is coming. So because of me, you're not paying out bigger claims to most of the city, right? So when I put it in terms he could understand like that, because of me, everybody's keeping their car safe. He's like, okay, I'll keep you on retainer. But anyway, I like this car because it was high. It was an SUV. It was high enough. And if we have time, I'll try to show you some video. I like the white car, the white color, because it showed the dirt really well. Keeping it clean was a pain, but I like this car, and it got pretty good gas mileage, it turns out. And I had to get rid of it. In fact, I got rid of it, I think, in late 2019. And so 2020, I've been driving this thing. I wish. Actually, I drive a Toyota Sequoia, but I don't have a picture of it. So I just went with this. I've always thought, if I had, my dream chase vehicle, what would it be? I have no idea. Sean Casey and that bunch from Discovery Channel and the Weather Channel, they've been driving their Tornado Intercept vehicle, which is a modified truck, and it's got so much armor and weight on it and bulletproof glass for the windshield that I'm sure the thing weighs 10,000 pounds. And I'm sure it gets wonderful gas mileage, of course. So, my goal is to try to stay out of the weather. We've got a saying that we'd rather be an observer to the storm and not a participant in it. So the thing I like about driving my car is that I know the limits that I can get away with. I know how it handles, and I'm not going to go take it into the baseball size hail willingly. If I'm driving the company car, sure. Baseball size hail, bowling ball size, sure, Ron, name it, I'll be there. So yeah, and that's the problem. When it's the company car, everybody drives it like it's the company car. And so, yeah, I've had very little luck with company cars, and I'd actually prefer taking my own car out. So why do we need storm spotters? I use the term spotters. You heard the term chasers. I'm old school. To me, spotters, if you use the word storm chasers, what do you think? What comes to mind? Crazy, fools. Are you nuts? Doing it for the thrill? Yeah. And what does storm spotter maybe connote or imply? Well, I'm spotting the storm, right? It's a little bit more noble cause. It's still crazy. It's extremely risky. But I prefer the term storm spotter because we receive training from the Weather Service every year. And let me tell you, in the 30-something years I've been doing this, we've seen a lot of changes in the technology and the way we do things. But there is still a need for storm spotters. You'd think with all the technology we have, we wouldn't need people to go out and mix it up directly with the storm. So why do we need storm spotters? So I've got another slide that'll cover this first point. Radar can't see everything. First of all, there's the curvature of the earth, and I've got a slide that will explain this better. When the Weather Service is trying to look for bad things in the sky, the radar is doing what's called a volume scan, and it can take anywhere from 5 to 7 minutes to do that. Most tornadic events are like on the order of 2 to 3 minutes. So what the radar could be looking the other way and not even see the tornado at all. It's always good to have trained personnel there at the event that's happening, the ground truth. Nothing beats a pair of trained eyes reporting directly what they're seeing. We allow the Weather Service, and we provide the Weather Service information, and that gives them the decision-making ability to either warn on something or not, or most importantly, not to warn on something. The Lubbock office in particular, the National Weather Service, is really good because they suffer from the boy crying wolf syndrome. If they put out too many warnings, people tend to ignore that. And so they only want to push the big red button when it really absolutely comes time to do that. We also can confirm or relay damage reports directly to the Weather Service, so that can go into the weather log, the event log. And we've actually got some places here on the South Plains. There's a volunteer fire department. I won't tell you who or where, but every time there's a cloud in the sky, they would report a tornado, whether it was near them or not. They would report a tornado. And so we'd always have, is anybody near XX location? What are you seeing? Oh, we've got this hanging down cloud, but it's not anything bad. Oh, okay, thanks. So we would always call it rumor suppression. There was always be, misinformation that they would try to get in on. So about that radar can't see everything. So this is something a lot of people don't understand. The radar beam goes in a straight line. Well, the farther away from the radar site you get, the higher up the radar is looking into the thunderstorm. And where do most tornadoes occur? In the bottom, from the ground up, right? So the farther away you get from the radar site, the more difficult it is to see what we need to on the radar to make an assessment as to whether there's a tornado on the ground. Now, that rotation can be all the way up to the top of the thunderstorm, but we're not seeing what's happening at the ground. And so one of the roles that we spotters provide is filling in that gap. We can say, yeah, oh yeah, it's got a wall cloud, it's got a tornado, it's got a whatever, or it doesn't. But the farther away you get from the radar, the more problematic it is, the higher in the storm the radar is looking at, as well as directly above the radar site is a cone of silence. That antenna cannot point straight up. So when the Weather Service was installing the Doppler radar network, they tried to do it in a way that adjacent radars would provide coverage. So we've got Amarillo to the north, Midland, Odessa to the south. We've got Clovis to the west, and they can provide what's happening over Lubbock. So radar can't see everything. Yes, sir. It is a technology. So in the old days, the radar beam would go out from the antenna until it hit something, would reflect off of it and go back to the antenna. And then that would be plotted on a scope and you could see the blob. So the harder the object that the radar antenna, the signal, excuse me, the more solid the object, the brighter the blob on the scope. I'm losing my voice. For a TV guy, not so bad, but for a radio guy, that's everything. So Doppler does the same thing. It sends the signal out and back, so you know where it's located in relation to the antenna. But Doppler measures, it's measuring the Doppler shift. What's the Doppler frequency shift? Well, how have you been sitting at a railroad crossing as a train's coming and you hear the train horn? It's high pitched, and then when it passes you, what does it do? It drops in pitch. That's the Doppler shift. So the Doppler radar measures the change in velocity of whatever it is the signal's bouncing off of and relative to the radar. So the Doppler can tell, is that raindrop coming towards the antenna or away from the antenna? And how fast is it doing that? So Doppler really changed, it opened up a whole new realm of possibilities for scientific research because we were able to see how the storm behaves internally. The latest development, this is about 2 or 3 years ago, they finished an upgrade to the Doppler system where not only can they measure the water droplets coming towards or away from the radar, they can now measure the polarization. Why is that important? Because now we can tell whether it's liquid rain or snow. So that Doppler signal is really fancy these days, where they can tell what kind of precip it's seeing, and if the temperature's right, is it snow? Is it hail? Is it graupel? Is it sleet? Things like that. So, but Doppler, that's the reason why it's called Doppler, is for the Doppler effect, the shift in frequency. Okay. What causes weather? Well, we're going to blow through this real quick. Okay. Any questions? And the folks on Zoom, speak up, type out, whatever. We've got people monitoring the Zoom stuff, so we don't forget you. Weather is caused by a number of things. The sun, the tilt of the Earth's axis, which gives us seasons, day and night, hot and cold, land versus water, all kinds of things. But we're just going to go through these real quick. The first basic weather thing is that air moves from high pressure to low pressure. Duh. If you push the valve on your tire, air is going to come out of it. Why? Because it's higher pressure than the atmosphere. So yeah, we have high pressure systems and low pressure systems. High pressure systems, the air is moving away from the area of high pressure, and low pressure systems, the air is moving towards the area of low pressure. It's kind of like falling down a hill into the valley below. In fact, that's the reason why you'll hear the weather folk talk about ridges and troughs. So a ridge would be a ridge of high pressure, and a trough would be the valley of low pressure. Okay, and if you can kind of imagine a ball rolling down a hill, that's how the air behaves. Pressure also affects stability. For severe weather, we need an unstable atmosphere. So if we have a high pressure system at the surface, obviously the air cannot go into the ground. So as the air sinks in a high pressure system, it spreads outward, and we call that divergence. And in a low pressure system, it's the exact opposite. We have convergence, where the air is coming together. Again, the air can't go into the ground, so it rises in a low pressure system. This is the reason why when we have low pressure systems in the spring, that's what brings us the bad weather. If you have a low pressure system over the Gulf of Mexico, we call that a hurricane. Okay, same idea. So we have imagine this same diagram, but because the earth rotates, we have what's called the Coriolis effect. So things don't go in a straight line, they go in curved lines. And that's what this is. We have cyclonic rotation or counterclockwise rotation around a low pressure. So hurricanes tend to spin counterclockwise in the northern hemisphere. And then high pressure systems or anticyclonic is clockwise rotation. So air comes and is spiraling out of a high pressure into the low pressure system. Okay. And the same mechanics and physics of low pressure systems over land work over water as well, but the added effect of the moisture of the ocean and the heat of the ocean causes these tropical systems known as cyclones or hurricanes. But we have the same effect over land as well. So here's an old-fashioned surface observation map. I know this is going to be hard to see. You can make out the outline of Texas and Oklahoma and Kansas to the north. The wind barbs are pointing to where the wind is coming from. Okay, so I'm going to, you may have to follow me on the camera. I'm going to go over here to the screen. So you can see where the air is doing this. Okay, see how the wind barbs are pointing to where the source of the wind is. So the wind is doing this over here in Arkansas and Louisiana. The winds are doing this. And then look up here in Colorado, the winds are coming straight out of the north. Okay, so if you're going to put a big L on this map, where would you put it? Where's the center of low pressure in this surface observation map? Any guesses? I heard it. Oklahoma Panhandle. Yeah, right here. So see, if we put the L here, notice how everything is spinning around it. Yeah, this was from 2015, November 17th of 2015. So this is 8 years ago. And this is a typical pattern that we would see in late fall. So we're getting, so each barb on the wind barb, each little segment here is 10 knots. So we're getting 25 knot winds out of the southwest here in Lubbock. And guess what the conditions are at the airport? Blowing dirt, right? Yeah. Out of the southwest. Yeah, it's Lubbock. Over here in east central North Texas, I-35 corridor, we've got all kinds of fog and drizzle. And as we get up to Oklahoma, now we've got thunderstorms. We got all kinds of thunderstorms breaking out here along the Oklahoma-Arkansas border and up into Kansas and into Missouri. So lots of stuff going on here. Something else I wanted to point out about this map. Look at all of the observation points in West Texas. That's thanks to the folks here at Texas Tech and the West Texas Mesonet. We've got a lot of reporting sites, and this allows us to really improve our forecasting ability. Now look at the entire state of New Mexico and look at how few sites there are there. And most of those mandatory reporting sites are airfields or air bases, okay? When you get down southern Texas across the border into northern Mexico, it's a void of data because there's hardly any weather stations in northern Mexico. Yes, ma'am. Absolutely. Well, it's the three dots. All the symbols here actually have a meaning, and I don't have time to go into it all, but So yeah, if I'm going to put my low pressure, so look at eastern Colorado, the top number, I'll pick this one right here. So this reporting point, I don't know if that's La Junta maybe. The top number is the temperature in Fahrenheit, so 33 degrees. The bottom number is the dew point, so it's 30. And the closer those numbers are together, you're going to have fog. Okay. So temperature, dew point, and then the flag, 30 knots out of the due north. 33 degree temperature with 30 knot winds. The wind chill's probably in the minus 10 teens. Okay. And look at all this wind. Oh, here's a 40 knot wind here. So the wind is just screaming out of the north. They keep that gate wide open up there. I don't know why they won't shut it, especially in the winter. Okay. So a couple of things to point out about this map. So yeah, I would put the L over the Oklahoma Panhandle. So this would be the cold front, and I don't have the triangles on it. Sorry for the weather nerds in here. There's supposed to be triangles. This would be the cold front. So warm air, cold air on this side. Okay. The green line is the dry line. So the dry line is separating the moist air from the dry air. And then on the back side, that red line is the warm front moving back to the north, because all of this mess is spinning counterclockwise around that L. Okay. And this is how our weather works in this part of the world. As these low pressure systems cross the continental US, we see our winds start out, maybe from the north or from the southeast. And as that upper level or the low pressure system approaches, we're going to see our winds slowly change. And as that low pressure moves off to the northeast, we're eventually going to see our winds go westerly. And then that cold air up in Colorado is finally going to hit us. Okay. So anytime you hear the words polar vortex, it's basically this. Okay. I hope this is helpful. I know you're all now you know everything you need to know to make your own forecast. Congratulations. Okay. So why do we have severe weather here the way we do? It's because of Tornado Alley, and this is a really dated map. Tornado Alley has actually shifted further to the east, and we're starting to see severe events back east, the Mississippi Valley, the southeast. This is the scary time of year because our severe weather season is essentially over. But now that we don't have to worry about hurricanes so much, the southeast United States, John, you guys in Louisiana, this is the scary time of year for folks living in the southeast and Dixie, okay? Because we'll get these storm systems in late November, early December, and we'll have tornado outbreaks. It's winter. How can we have tornadoes? Anywhere you have the cold, dry air and the warm, moist air coming together, you're going to have all the ingredients necessary for bad things to happen, regardless of where you are. But typically, we're favored for this kind of a setup because we have the plains, the Great Plains. So we've got the cold air coming down from Canada. We've got the moist air coming up from the Gulf. We'll have an upper level disturbance that comes across like that low pressure system, and then voila, severe weather. Okay. Let's take a look at, how am I doing on time? We got an hour. Okay. This will be on the final, might take notes. What defines severe weather and what constitutes some severe weather threats? Well, this is a good thing. How are we doing on Zoom? Anybody, any questions? We're good so far? Are they sleeping? Are you guys sleeping out there? Let me tell you. Okay. The Weather Service has some interesting criteria on what they think severe weather is. These are the rules. So it's not going to be issued a warning unless it meets one of these three things. Okay. Winds at least 58 miles per hour. That's 50 knots or greater. Hail at least 1 inch in diameter or greater, or if there's a tornado. Okay. Those are the three biggies. So if the winds are under 58 miles per hour, not severe. If the hail is smaller than 1 inch, not severe. In fact, I think it was 15 years ago, the hail criteria was 3/4 of an inch, quarter size, about the size of a quarter. Okay. And then they bumped that up because we were seeing too many hail events that, 3/4, that's nothing. You take a young cotton crop, a newly planted cotton crop that's coming up. It doesn't take 1 inch hail to do much damage. In fact, you can have small pea-size hail will strip a cotton plant. A watch means that the ingredients are coming together, and so we're waiting for it to happen. We're watching for it to happen. Whereas a warning means we're actually seeing it happen. The kids today, The Weather Service is using a watch means tacos are about to happen. A warning means tacos are being served. And I don't understand the logic behind that, but anyway, I guess the kids get it. But yeah, the difference between a watch and a warning, a watch is we're watching for it to happen, whereas a warning is it's happening. Okay. So these are the three things that the Weather Service uses to define severity. Okay. So let's look at some threats. Severe lightning. Is there any other kind? Amazingly enough, lightning is not a criteria for severe weather. It's hard to have a thunderstorm without thunder, and you can't have thunder without lightning. So, and let me tell you, the one thing that scares me to death is lightning. Tornadoes, not so much. High winds, big hail. Yeah, okay. Lightning, there's no rhyme or reason to it. It's going to get you. And I try to mitigate being a target for lightning as much as I can. But lightning is not a severe criteria. It's kind of interesting. High winds. This was a picture I got up near Plainview, and we're looking to the west. We're on the north side of town. I think that's the Walmart distribution center on I-27 on the north side of town. And I was watching this thunderstorm roll in, and it was kicking up all this dirt on the outflow. So we were getting 60-mile-an-hour winds just from the outflow of the thunderstorm that was well to the north. What's amazing to me is people do not realize that wind by itself can be a bad thing. Oh, well, it had to be a tornado that knocked my mobile home over. Well, not necessarily. You can have the right kind of winds to do just as much or even more damage than some tornadic events, but people just absolutely refuse to believe that it wasn't a tornado. We had an event earlier this year, in fact, back in October, that knocked down a lot of old growth trees in my neighborhood. My neighbors were just convinced, oh, it was a small tornado. I was like, no, I don't think so. And there's things that we can use to determine whether it was tornadic or not. You know, if debris goes in all directions, tornado. If the debris is all scattered in one direction downwind, high wind event. Okay. In fact, see if you can figure out this picture. So this was May of 2006, Anton, Texas. This picture is very confusing. Anton is just northwest of Lubbock, and we're actually just off the highway. The railroad tracks are just to the left, and all of the metal agricultural buildings are to the left side of the picture. To the right side of the picture is the highway, okay? But see if you can make sense of what this damage is trying to tell you of what happened here in Anton. And I don't know what happens in Anton. I don't know why they have offended God Almighty, but Anton gets hit regularly. This was just one case. In fact, this case, the secret to what you're seeing here is Anton was hit twice, okay? So the first thing that happened, because notice all of the debris in the foreground is on this side of the telephone poles. And it's like, how did that get there? Because what direction are all the telephone poles leaning? They're leaning the other way. So it doesn't make any sense. Well, the answer is Anton got hit twice on this event. The winds were out of the, let's see, that would have been the west-southwest. And so like 60 to 80-mile-an-hour winds knocked all the telephone poles onto the railroad tracks there, okay? So that's what killed all of the poles. And then an hour later, a second storm system came out of the northwest and had similar winds coming the opposite direction. And that's why all the metal is in the foreground and around the poles there. It got hit twice from two different directions. And my favorite part about this is the sheet metal taco hanging on the power line there, right? I've seen trampolines do that too. It's, but this is characteristic of straight line wind damage. And you can have high winds, you know, roll over 18-wheelers, roll over mobile homes. I don't have problems with mobile homes, but it's the mobile part that gets you into trouble, especially during severe weather. That's the reason why we say get to a sturdy structure. One that's not meant to move, especially in high winds. So yeah, high winds are a big deal. Hail. I actually took this picture back in early October. This was last month. We had a hail event here, and this was at my house. The spiky hail. Oh, fortunately, there wasn't a whole lot of it, but what I managed to grab, I mean, look at that. What's the criteria for severe on hail? 1 inch. That's almost 2.5, 3 inches, that one on the left. I heard it hit the house and I went, what? So yeah, and fortunately, there wasn't a whole lot of this. It was mostly smaller, but yeah, this goes to show you we can get big hail, nothing flat. Okay, so DG, what's the biggest hail you've been in? Bigger than softball. It was not fun. Not fun at all. you know, 1 inch hail, baseball size hail, gusting to softball size hail, that starts getting dangerous. And I can't remember what the largest hailstone measured was. It was just recently, but it's, close to 8 to 9 inches. And what impresses me is that has to be one hell of an updraft in order to have that big chunks of ice still stay up in the sky. And then finally get so big that even the thunderstorm can't juggle it anymore and it all falls to the ground. What causes big hail is it starts out in small hail and it keeps going through that process where it gets another layer of ice, gets sucked up, freezes, and then on the way back down, it collects another layer until finally the hail gets so big that the updraft can't keep it up there anymore. And the biggest hail is usually associated with supercell thunderstorms. We'll talk about that here in just a bit. Oh, that's hard. I've been in it so many times in so many places. The last big hail event I was in was probably up near Levelland, west of town. For some reason, Ron just gets a kick out of sending me into the hail. If I'm driving the company car, great. If I'm in my car, I don't think so. I'll hold it out because this does some serious damage. I've never lost a windshield. I've cracked many, but I've never lost a windshield. In fact, one of the reasons why Ron came to me back in the late 90s was because he kept sending TV crews out to get weather shots. They had no idea what they were looking at. And he said, I'm tired of them coming back minus windows in the company car. So you guys know what you're looking at. Come work for me. And I was like, okay. So another threat, tornadoes, of course. We'll talk more about this particular one here in just a little bit. And of course, flooding. I don't think us West Texans fully appreciate the danger that flooding is. Because it's so flat, we don't worry about flooding. But in our city planners, God bless them, decided that we don't need sewers, we just use the streets for that. So every street in Lubbock becomes a canal whenever we get severe, heavy rains. This was near, I was gonna say Quaker, I was just weird. Yes, exactly. Because all the water is going to go to the 1 or 2 low spots in town, right? And we already know where those are. So, 98th and Quaker, the worst I saw it was 4 feet of water at that intersection. There's what's that burger? Blue Sky, I think, is over there. Yes. Yeah. In fact, Lubbock Fire Rescue was doing water extractions. They were actually rescuing people in cars down there. It was nuts. So it does happen. Turn around, don't drown. So what do we look for in thunderstorms? So this is a very simplified version of a garden variety thunderstorm. We're looking west, ignore the southwest and northeast. This is basically an ideal view if we're looking to the west. The upper level winds are coming from left to right. The flat cloud on top, that circular bow shaped thing on top, that's the anvil cloud. The main storm tower in the middle is the primary updraft. That's all the air going up. And people have asked me, how fast does that air rise? We're, anywhere from like 150, 200 miles an hour, going straight up into the sky. That's how fast those updrafts are. The flanking line is the line of smaller cells. Eventually the flanking line will move into the parent storm and become the dominant cell until, it gets replaced. So it's this continuing cycle. The rain is off to the right. And in this particular case, we've got a wall cloud with what looks to be a tornado and the rain-free base. So as a storm chaser, as a storm spotter, I'm trying to orient myself relative to the rain. I want to stay out of the rain, but I want to be close enough to see the wall cloud or the tornado and where that's going to develop. And how we know where that is going to be under the primary updraft. Okay. One measure of severity for us is the overshooting top. The updraft, that anvil cloud will hit what's called the tropopause and spread out like it's hit a sheet of glass, the glass ceiling, ladies, right? The thunderstorm cloud material will hit that tropopause and spread out like it's hit an imaginary invisible pane of glass. But the updraft can be so strong that the momentum and mass will continue, and some of that cloud material will actually punch up through the anvil, and we call that an overshooting top. And when we see an overshooting top, that's an indication of how strong the updraft is. The stronger the updraft, the more hail it can carry, the bigger hail it can make, and the more bad things it can do later on. But this is a very simplified diagram. I've never seen a thunderstorm this laid out. I wished I could, but this is just for so we can explain it, right? Explanatory purposes. After the thunderstorm is over, usually you'll see the mammatus clouds, the big bulges. Hope that doesn't need further explanation. Why is it called mammatus? Because it's like mama? Never mind. Okay. We're keeping it PG, right? So let's look at an example. So this would be the distant view. We're looking at this from, 20, 30 miles or further away. And by the time we get up close enough to see the wall cloud, usually we can't see the storm tower above us because there's either low level clouds or we're too close to it. Yes, sir.
In your vehicle, are you looking at a computer and visual?
Yes, both. I usually I have a laptop, and so I'll have the radar pulled up so I know where I am relative to the storm. I know which direction the storm is going. In the old days, it was just dead reckoning, that way. We'd have maps, we didn't have GPS. The three things that every storm chaser needed back in the 90s was a bottle of Rain-X to keep the rain, you'd polish the windshield to keep the rain off. We needed Roads of Texas because that was the Bible of road atlases that had every highway of Texas on it. And what was the third thing? Oh, a burrito from Allsup's. That was tradition, right? Allsup's burritos. Every storm chaser knows that you stop at Allsup's and get a fried burrito. Ooh, they're good. Probably not so good 2 hours into the chase later, but So here's an actual photograph. So now we're on the opposite side. We're looking to the south. It looks like we're looking to the south. The sun is setting into the west, off to the right. Notice the anvil cloud is kind of back sheared. It's going against the storm flow. But look right above it, we've got a huge overshooting top, that big old bulge at the top. That's the overshooting top indicating where the primary updraft is located. We've got a flanking line off to the right there. So that cell is eventually going to become mature and will be the main storm in this cycle that continues. But what do you notice about that flanking line? Is that storm cloud going straight up? No, it's bent over. This is a visual indication that the upper level winds are not only strong, but they're increasing with height. And that's really bad for severe weather. These thunderstorms in the environment that they form can continue in long-term cycles well into the night. The weather that hits us about 6 to 8 hours later will be hitting the Dallas Metroplex. And if the storms are very well organized and the conditions are just right, those storms can continue well into Arkansas, Louisiana, and the American Southeast. So this is what we'd be looking for: an overshooting top, a back sheared anvil. You can kind of see striations. Let's see, did we talk about that? Yeah, well, I've got better pictures that'll explain that. Okay. So this is what we're looking for. So we're trying to notice you can't see a tornado from this vantage point. I can only look as a distant observer. And so my goal is to try to get closer to this storm, stay up with it until I can see what I need to report on it, along with all the other chasers. So a special class of thunderstorms are supercells. These are the baddies. Here's one, Olton, Texas. I showed you that tornado picture. Well, here it is from another distant view. This isn't my photograph. I forgot who took this, but this was up near Olton, Texas back in 2007. And that sucker it's got this corkscrewed appearance. It's got those lines and everything. Everything about this picture suggests that it's rotating, but it's a still picture. But tell me the storm is rotating without showing me it's rotating, kind of a thing. Yeah, everything about this is suggesting rotation. Very flat, rain-free base. We've got the tornado there in the middle. It's got this skirted appearance. I was on this storm, and this storm was putting out baseballs. I was near Olton. So yeah, this was not a fun system to play with. This was up near Kansas. And again, see the lines that we call those the striations. It's like stacked pancakes or the mothership. Remember Close Encounters? My students have no idea. Close Encounters. It's like, yeah, it's like the mothership in Close Encounters. What's that? But the older people get it. It's the mothership coming. That's what we describe it. And yeah, I don't know if this one eventually produced a tornado or not, but it's very ominous looking. Okay. This one, oh man, this is up in Nebraska. And again, tell me this thing is rotating without telling me it's rotating. Everything about it is just, it's circular. It's got a barber pole appearance, the striations, everything about it suggests this thing is just spinning like mad. And I'm sure this thing had a lot of hail coming out of it. This is what we would call a high precipitation supercell. It's putting out rain everywhere, and it's throwing hailstones out in all directions. This is bad for storm chasers and storm spotters because we can't see if there's a tornado. It's hidden by curtains of rain there at the bottom. And we wouldn't want to go near this thing anyway, because these are the worst of the worst. But the good news is radar, these show up on radar very well. So we don't have to go near these. The radar can handle these very well. The radar can see what's inside and does a very good job of tracking the nasty things. We call that the bear cage. When we go playing, near the area where the tornado is going to be forming, that's called dancing with the bear cage. And I've only done that a handful of times. There are old chasers and bold chasers, but there's never any old bold chaser, kind of a thing. So, all right, let's talk about tornadoes. So again, the Weather Service has some criteria that they use to define what a tornado is. And it's these three things. A tornado is a violently rotating column of air, check. Attached to a thunderstorm, check. And in contact with the ground. Pretty simple. There's only one exception to this. The exception being what we call land spouts. Land spouts technically meet this criteria, but they're not nearly as violent as your garden variety tornado. There's a slightly different formation process. Water spouts as well, a tornado over water. Violently rotating column of air attached to a thunderstorm in contact with the ground. We have to have all three of those things. If we don't, technically it's not a tornado. And this is one of the challenges that spotters face, When do we call it a tornado? Well, I'm going to test your knowledge. I've got some pictures we're going to find out. Now, if it doesn't touch the ground, here we go. We call it a funnel cloud. We've got the funnel, but notice there's no visual indications of contact with the ground. So we would call this at best a funnel cloud. This is that same tornado from that Olton, Texas storm from 2007. We're up close and personal with it, okay? So is this a tornado? Looks like it. Go ahead. Yeah, there's no thunderstorm. So yeah, we're lacking one of the three. Violently rotating column of air in contact with the ground, but there's no storm. So technically this is not a tornado. What do we call these? Dust devil, okay. I think this was near White Sands because I'm trying to think of the instrumentation there on the ground. Okay. Is this a tornado? Maybe, but what are we lacking? What can we not see about it? Yeah, we got too much clutter in the way. So we're driving through Olton. We're looking to the south. We're going east on whatever road that is. I can't remember, but it goes from Olton to Plainview. And we're looking to the south. We had just core punched the hail, only golf ball size. So all of the rain is behind us off to the right, and we're looking to the south. I was listening to the two-way traffic on the radio. And, oh yeah, it's got a great looking funnel, and we're in just pouring rain. And then, it's like Moses parting the Red Sea. The rains part, the hail stops, and I'm looking, and I look to the south, and I'm going, oh, hello, this is what we see. So at the very least, this is a funnel cloud because we cannot confirm if it's in contact with the ground or not. It doesn't look like it, okay? So we keep going east. We're just outside of Olton on the east side. We're still looking to the southeast now. Is it a tornado yet? What are we lacking? Still not in contact with the ground. Okay, how about now? Why? Why is it a tornado now? You see the debris cloud underneath it? We now have confirmed that this violently rotating column of air is in contact with the ground. So now it's a tornado. But what do you notice? The condensation funnel is not all the way down to the ground, okay? It still looks like a funnel cloud, but that debris cloud underneath it gives it away. It's a tornado at this point. So you don't have to have a solid cloud material all the way down to the ground for it to be a tornado. This actually is a tornado because of that debris cloud on the bottom, okay? Yeah, and it actually grew in size, and it actually filled in all the way to the ground as it crossed the highway in front of us. We chased this thing. This was a long-lived system. It was on the ground for at least 45, 50 minutes, traveled probably 60 miles. So it went from Olton, south of Olton, up through, what would that be? Southern Hale County, and finally dissipated just northwest of Plainview. And so I looked on the map and I was like, man, this thing was on the ground forever. Fortunately, it damaged a couple of houses, didn't injure anybody. But after this tornado dissipated, the second tornado that this storm formed hit Tulia and I think killed 2 people. So yeah, very bad system. And yeah, big hail, baseball to softball size hail. In fact, this storm was slinging hail out in all directions. And the only way I could stay out of the hail was to go dance with the tornado. And I didn't really want to do that. But it's either the tornado or the big hail. What's it going to be? Yeah, okay, tornado. Yeah, these are the options we faced. So I like to present this for the kids, but it bears repeating for the grown-ups as well. Where do we take shelter? The Weather Service basically says, get down to the lowest level of whatever structure you can. Basements are really good. Get under something sturdy, cover your head, and stay in the shelter until the storm has passed. Okay, that's simple enough for kids to understand. Basically, my rule is put as many objects between you and the storm as possible. So the most interior room you have in your house or your apartment or your office building, preferably in a basement if you have one, but if you don't, a bathroom. I'm old enough to remember, what started my adventure in severe weather was my mom putting my brother and I in the bathtub in Amarillo and putting a mattress over us. And we're like, Mom, this isn't how we take a bath. We were too young, but that's what you do. And most bathrooms are in the most central part, and the plumbing helps reinforce the walls. So most bathrooms, are great for this. I would avoid any kind of a room that has an exterior window because debris is going to come through that window and turn it into shrapnel in those high winds. So yeah, put as many walls between you and the storm as you can. All right, that's DG's rule. Now, what about cars? This gets interesting. So if you're out on the turnpike in Kansas and the tornado is approaching and you're driving on the highway away from the tornado, what should you do? Keep driving. Okay, duh. A lot of people get caught unawares. This is what always shocks me. People ask me, what's the most dangerous thing I do when I storm chase? It's other drivers. Okay, I've got years of experience being in bad weather and driving in bad weather. They don't. And what do people do when they're presented in an unusual situation for the first time? And they do, what do? They panic. They make bad choices. And their bad choices can have big ramifications for me and the other drivers on the road. So if you're in a place where you can get away from the storm, go for it. Open country is one thing. If you're caught here in Lubbock as the tornado's hitting town, you still have to obey the traffic laws. Red lights are there for a reason. Probably can't escape the tornado in your car if you're inside of an urban situation. But if you're out in the country, go for it. But this is one of the pictures I love showing the kids. What if I'm in my car in the garage, DG? Okay, well, you tell me. Cars can easily get picked up. I've seen tornadoes lift up railroad cars, tank cars, locomotives. I mean, we've all seen tornado damage. Cars are nothing. No, it wasn't. But I tell the kids, you don't want to be in your car. A car is not a safe place to be as it is the building. Now notice the brick house behind it. Yeah, there's superficial damage. We've got shingles missing off the roof, but the building is still there. In fact, what impressed me was the garage door is still mostly in place, because usually the failure point for most houses is going to be the garage door. Once the garage door gives in, that wind gets in. You remember the old adage, oh, you've got to open a window so the pressure is equalized. I hope we got away from that. That was the kind of the 70s mentality. The air pressure differential is so bad that you have to open a window, otherwise your house will explode. No, it's not the pressure difference. Can you survive 50-mile-an-hour winds? Yeah, exactly. How about 80 miles an hour? Exactly. It's not the wind that gets you. It's the stuff the wind is carrying that gets you. I tell my students, roll down, you're in a car following a truck and you roll down the window, you're doing 75, 80 on the interstate. You can stick your hand out there and do the wing thing, right, with your hand. The wind is fine. But if that truck is carrying gravel ahead of you, bad news, right? You want to get as low as you can in the wind. Make yourself as small of a target as possible. What impresses me are these 1x6s that went through the car door there on the driver's side. It took out the passenger window there. But look at the brick structure behind it, relatively unharmed. You would have been better being in the garage than you would that car. Yes. Zoom is checking in. For the most part. And the reason why, because that's our typical flow pattern, but tornadoes can go any which way. The Gerald tornado that wiped out Gerald, Texas was an F5. It went due south and it missed I-35. That was the miracle. I-35 traffic was backed up because what? Everybody was watching the tornado and it was just a half mile away from them. But if that had been on the freeway instead of going through Gerald, it would have been a whole different story. So tornadoes can move any which way. In fact, I hope if we have time, I think we're doing okay. I want to show you 2019, the tornado that almost took out Tahoka. And it started going east, then it went south, and then it went southeast, and then it went south again. So these things can change on a dime. And that's the scary part. So yeah, tornadoes, they're steered by the wind. So whatever the winds are that form the storm and are feeding the storm, that's what's going to determine the direction of everything. Yes, sir.
My wife was in May 70.
Yeah. Uh-huh. Oh, yeah. So the May 11th, 1970 tornado actually started a mile north of here at 4th and University. It tipped over one of the light poles at Jones Stadium, and that's how it began. And it just went down 4th Street through the middle of town and out to Amarillo Freeway, out to the airport. In fact, that was one of Andy Anderson, who was the chief meteorologist at the Weather Service a long time ago. He actually had the barograph. So the weather pressure at the airport, that was where the Weather Service was located, as the tornado passed over the weather bureau, and you see the pressure drop. It went off the scale, and then it comes up again after the tornado passed. And that led to this belief of, oh, well, it's the pressure that causes your house to explode. No, it's the 80, 100 mile an hour winds blowing your house over, like the Three Little Pigs and the Big Bad Wolf, right? Yes, there was actually 3. The second one hit Park Tower, and it quickly dissipated. And the third one actually hit out near North Loop 289. It actually caused some damage out by, what was that, Idalou Road. So yeah, there was actually multiple tornadoes, but yeah. Fortunately, I was in Amarillo and I was only this tall. So, but I remember my grandfather worked, he was a civilian for the Air Force. He closed Amarillo Air Base, and they eventually transferred him down to Reese. So we would come see my grandparents all the time on the weekends down here in Lubbock. And my grandmother would take us downtown. And I had no idea what a tornado was, but I knew it was bad because, years later, 5, 6, 7 years, there was still damage downtown. The Metro Tower was still, corkscrewed, and oh yeah, it was a mess. So let's talk about the Fujita scale. Everybody talks about the F scale. Dr. Theodore Fujita, Ted Fujita, was out of the University of Chicago. He was a Japanese meteorologist who was studying high winds and tornadoes in particular. And so he created this scale. So what is the highest F rating of a tornado? Anybody know? A 5? Yeah. Okay. EF5. We'll talk about that. We're going to talk about the F scale and then the EF scale. EF scale is enhanced Fujita scale. So we'll talk about that here in a second. Is F5 the highest? Really? I always wanted to know. So they have, I'll show you the chart where they separate the winds. Do you think a pane of glass cares if the wind was 239 miles per hour versus 240 miles an hour? No, it doesn't. And so I always wondered, how the heck did they separate the wind speeds? Well, it turns out Ted Fujita was trying to fill in the gaps. And this is a complicated diagram, but notice the curve that goes up the scale. That's his F scale. So here along the bottom is the Beaufort wind scale. We hear that a lot. It's a category 3 hurricane or a category 4 winds. So the Beaufort scale is typical for, coastal and water kind of winds. And then you've got the Mach number, the speed of sound. And so what Ted Fujita was trying to do was kind of fill in the gaps. He was trying to find a scale that would work with the Beaufort wind scale and then these tornadic winds as because back in those days, all tornadoes were thought to be the same. There was no difference. A tornado is a tornado. But then when he started doing these damage surveys, especially after the Lubbock tornado, he realized not all tornadoes are the same. Some are worse than others. And he did the survey for Lubbock and had what he called suction spots, where it looked like the tornado would do this spiral and it would actually go over the same area several times. And Lubbock, I think, was the first official F5 rated tornado in the United States. There were some others that came close. I think Waco was hit a couple of years earlier than Lubbock. But most of his research here in Lubbock went into his developing the Fujita scale. But notice up here, what's this number here? F12. Mach 1. So the laws of physics, as best we understand, winds are not going to travel at Mach 1. It's physically impossible. The highest hurricane speed is not even going to come close to that. And yes, as we already figured out, F5 is typically the highest damage. It's a damage scale. It's not really a tornado scale. So the Fujita scale is basically, if we can look at the damage, maybe we can figure out what the winds were needed to tear that thing apart. Okay, so right away, there's a lot of problems with that approach, but we haven't found anything better other than directly measuring tornadic winds with Doppler radar, and we don't have enough of those to really do that. But it's interesting to me that this curve literally sets those speeds. I was always wondering how he established those speeds. So he was trying to find kind of a magic separation of all of his Fujita scales going from F0 up to F12 at Mach 1. But what he quickly realized is that anything after F5 is kind of irrelevant. And I'll tell you why. Historically, so the Fujita scale is based on man-made objects. If a tornado is in a cotton field, if a tornado is in a forest and there's no one there to see it, does it exist? Well, according to the Fujita scale, no, it doesn't, because if it doesn't tear up anything that's man-made, we can't analyze the forces needed to tear whatever it was up, okay? So a tornado in the middle of a cotton field is useless. It's great. It's not gonna hurt anybody. Sorry for the cotton farmer, but there's no equivalent vegetation damage scale. You know, no two cotton plants are the same. No two trees are alike. You know, a bare tree versus a tree full of leaves. So the Fujita scale is immediately based on damage to man-made structures and man-made objects. And that's one of its first flaws. And typically the classic definition of F5 damage is it scours the foundation of the building. The only thing left is the foundation of the building. Okay. And in some cases, even scoured pavement. Well, this is where the asphalt used to be. You can see the caliche where it was. So scoured pavement was always the upper limit for F5. Well, what's the difference between an F5 and an F6? Well, if there's nothing left to destroy, anything after an F5 is kind of irrelevant, right? So Ted figured out really quick, anything over F5 is irrelevant. So, but yeah, it's always fascinating. The highest F number he had was F12. Can you imagine what that would be like? Ugh. Fortunately, it's impossible. By any of the physics we know, an F12 is physically impossible. They don't reach the speed of sound. Nature kind of has an upper limit, but the damage that it can do. And I've always been impressed by his descriptions. F0, light damage. F1, moderate. F2, considerable. F3, severe. F4, devastating. And F5, incredible. I like the adjectives. What's the difference between incredible and devastating? I have no idea, but that's the difference between F4 and F5. So we were using this scale for many, many years and realized it has a lot of shortcomings, not the least of which is the tornado in the forest paradox. You know, a tornado really doesn't exist unless it destroys something, and the Weather Service has no means of recording it. We can just mark that there was a tornado there, but if it didn't tear anything up that was man-made, it's not really useful for us. So they came back later and actually the wind engineering and meteorological programs here at Texas Tech helped create the enhanced Fujita scale, or the EF scale, and it's a lot more useful. So we had 30, 40, 50 years of storm damage assessments, and engineers went back and looked at that and said, okay, the first thing that they really discovered was the wind speeds were too high. So we started bringing the wind speeds more realistically down, and it's a lot better scale. The EF scale is much more useful. Weaknesses, it's based solely on damage caused by a tornado. It's very subjective. You know, no two houses are built the same. So one house may stand and the other may not. Again, if a tornado is in the field and there's no damage indicators, was there a tornado there at all? It's always based on the worst damage. So the Weather Service, when they do their assessments, they're looking for the thing that got destroyed the worst, if that's possible. Well, how do you know? It's not there anymore. It's been destroyed. Yeah, I know. That's why it's the worst. I also noticed, especially in the late 90s, the rating for a tornado was always biased, especially if a big politician would visit the damage area. President Biden's going to be visiting. Oh, well, it's not an F2, it's an F3. You have to make it worse than it really is. So yeah, there's a lot of bias in there. And yeah, the F scale was greatly overestimating the wind speeds above everything over an F3. And so the EF scale kind of tamped all that down. One of the big issues with the EF scale was we wanted a scale that could be reverse compatible with the original F scale. And so that took some doing, but it's amazing the work they did. So here's the original Fujita scale on the left versus on the right. And you'll notice the high end, 200, again, is a glass window going to care if it's 260 miles an hour in an F4 versus 261 miles per hour? It always thought that the scales were arbitrary, but when you look at his chart, there's actually a logical reason there. But over on the right side, it makes a lot more sense. An EF5 is anything greater than 200 miles an hour. And that's nasty. 200 mile an hour winds is going to cause a lot of problems. But the EF scale is much more useful. It still suffers from the same problem. If a tornado is out in the middle of an empty field, is it doing anything harmful? Not really. Sad for the farmer whose land it is, but other than that, Tahoka tornado back in 2019, it crossed a lot of open agricultural area, thank God. And it just barely missed Tahoka. So the Fujita scale is what it is. It's a damage scale, and we kind of infer what the winds were like based on the damage it causes. And it's been in use since 2007. Okay, and here's an example. So this is the Dallas area. The two yellow triangles are tornadoes that were over the Dallas metro. To the left is Fort Worth, just off the side of the screen. You see Dallas County and DFW Airport. So this is something I noticed, okay? Again, the whole key to the Fujita scale is it's got to tear up man-made stuff. So those two yellow triangles are the worst tornadoes because they went through the Metroplex. This was back in 2019. Yeah, October of 2019. So an EF3 in North Dallas by the airport there. And then the Garland tornado was an EF2. Why? Because there's plenty of stuff in the Metroplex to destroy. Okay, look about 60 miles to the south in Waxahachie. It looks like these series of tornadoes to the south were produced by the same storm, and it dropped 1, 2, 3, 4, 5 tornadoes. That's a bad situation there. But notice the EF scale on those. A 1, an EF0, an EF0, EF1, EF0. So I've always wondered, what if that southern thunderstorm actually passed through the Metroplex? I'm sure the numbers would be much higher because it has more to damage. Mostly through agricultural space down there on that lower system, it didn't hurt anything, or it didn't hurt much. And the reason why those tornadoes are rated the way they were is because that was the most significant damage they could find to rate the tornadoes. But I'm like, what if that secondary line was a bit north 60 miles? What would the difference be? A lot more to destroy. Those winds would probably be a lot higher. Just something to think about. Okay, finally the good stuff. And I've got, 20 minutes left or so? Okay. Actually, no, I'm going to blow through these because this was nothing. So this is May 4th. Yeah, whatever. Okay, sure. Blah. There. Okay. It was the next day, Sunday, May 5th. That was the biggie. Okay, this is Tahoka, Texas. And the funny thing is, we were not expecting tornadoes this day. We were expecting hail, rotating thunderstorms producing hail, but we were not expecting tornadoes. And boy, did we. So this is what it looked like. We're in southern Lubbock County, looking back to the northwest. I think we're near New Home, kind of that area. Looks benign. It's gray. We were playing, Ron had me going, and I'm in the Yukon, notice the white hood there. Ron had us going all over the southern part of the county. We were playing in southern Lubbock County and northern Lynn County. And I was looking for the biggest hail I could find without trying to find the big hail, if that makes sense. And we came across golf balls. I think we had some golf balls in southern Lubbock County. And so, we're just doing this orbit of southwest Lubbock County. Okay, well, we'll go back out to New Home again, blah, blah, blah. And we got into this heavy rain curtain. And when we came out of the rain, I was like, well, this is interesting. All of this stuff is moving to the south at a pretty good clip. And Ron says, we're starting to get reports of something in Lynn County. And he was giving a county road, and we looked it up on the map, and it's like, okay, that's going to be to our south. Yeah, that's going to be near Tahoka. Holy crap, to the south. So we look to our right, and this is what we see. ragged, not very well defined, but oh my gosh, definitely rotating. We've got all kinds of cloud debris there at the surface. And again, notice that it's not a solid funnel from the cloud to the ground. It's raggedy, but we've obviously got rotation there at the surface. Yeah, we've got a tornado, Ron. Holy cow. So now we're trying to get into a position where we can get a better view of it and watch it as it. So we're looking to the south and it's moving to the left. It's moving to the east. Okay. 20 minutes. What a difference 20 minutes later makes. Now, you will know if DG takes the picture because I always have something stupid in the foreground. My radio antenna on the car, for example, or a telephone pole or a one-way sign. You're going to see the best of my photography. I'm not a photographer. Okay. I'm a radio guy. Pictures are irrelevant. I can describe the scene, but I can't take a picture of it. So here we are. We're looking south on 87. You know, Tahoka is that way. And we're looking to the south. The storm is moving. Now, there's actually two tornadoes here. I don't know if you can see that. The dark cloud here on the left is obvious. But if you look further down the highway, we've got another one, a secondary smaller tornado that's orbiting the first one. Okay. Huge area of circulation. This was May. Farmers probably hadn't planted yet, or they had just planted. So we've got a lot of soil that's just loose in all the fields. And this sucker is going to take advantage of that dirt. So I managed to pull off and I'm looking back. This is looking back to the east. Yeah. So now we're looking east and I've got a second wall cloud behind the first one. So I'm looking back over my shoulder to the left and I'm like, oh, we've got a second system. Need to keep an eye on that. Let's go back to the first system. Yeah, obviously, you know, one of my pictures. So there's the second wall cloud behind the one-way sign. And if we look back to the south again, we've got this monster. So that thing is now filled in and it's just growing and it's becoming huge. Let's see. Oh, I think I've got video here. Nope, let's see. Okay, so now we're looking. We get through Tahoka, it's crossed 87, it's narrowly missed Tahoka. Now we're on the east side of Tahoka on 380, just on the east side of Tahoka, looking east towards Post. Can you see the tornado? You have no idea where it is. It's that blur on the left behind that telephone pole. It is so wrapped with dirt and dust, you can't even see the tornado itself, okay? It's nasty. So I swing the camera further to the left, and now we're looking to the north. Can you see the tornado now? Not really, but you can kind of see the edge of it. So we got blue sky. We've got a couple of wind turbines here at the ground. But yeah, so the tornado is right there on the right side of the image, and it is so full of dirt, you can't even tell it's a tornado. This thing was a beast. Okay, now, how do I make the video play? Let's see if I can do this. This is my wife takes better pictures. Okay, let's see. What if I right click? Can I just click on it? Maybe I do that. Oh, I've got all this cool video. Oh wait, maybe it's the next one. No, that was it. Yeah, because it's got drat. The technology has foiled us. We traveled down 380 a little ways and we get close to this thing. Somebody was asking how close I got to it. I got way too close, even though I'm like a couple of miles from it. The circulation was so wide. I was getting 80-mile-an-hour winds a couple of miles away from the tornado here at the surface. And I'm getting pelted with mud. I need to make this play somehow. Anyway. Power lines come down on top of us. I mean, it was really a bad deal. So here it is after it crosses the highway and goes to the south. And now it's playing with these wind turbines. And I thought, I'm going to get to see wind turbines come apart. You know, the guy that I am, I like to see destruction. Actually, I don't really live for the chase, and I'm not in it for the thrill of it. But I was like, I want to see if these wind turbines are going to hold up. And they did. Tornado went right through them. The wind turbines are like, ha ha. Nothing you can do. Turns out those things are well engineered. They're designed for this this part of the world. But you can barely make out the tornado there, but look at all the dirt around it, This was one of the nastiest, dirtiest storms I've ever had the pleasure to come across. And yeah, it turned my car brown. I didn't have a white Yukon after this. It was brown. And I think up until I sold it later that year, I was still pulling mud out of the weirdest places in that car because it was just everywhere. See, here's another video. I gotta make this work. Yeah, because on my system, I could just click on it and it would play. Yes. Oh, Colleen is going to assist.
All right. Are you sure that's a video? Because
Yeah, it is, because it's blurred, because we're in motion there.
it would be blurred if you were in motion and you took
Well,
a snapshot.
If I
too.
took a picture, it's gonna be blurred anyway with the sign in front of it. That's the next slide. Actually,
Yeah,
let's go to the next slide, because I think that may be. Well, maybe not. Yeah, that's a video too.
do they, okay, where's the? Hang on here. How
Go
far
way
down
keep
are
going,
we on this?
keep going.
Wait a minute, let me do this. View. No, that's not it. The slide sorter. Here we go.
Yep.
Okay, here. I think anything with an asterisk is
Is video.
supposed to be a video, but
Yeah.
I'm not sure it got.
Oh, I saw a play bar. Yeah, right. Oh, right there, right there. Hit that.
Yeah, but it's not. PowerPoint knows them to locate the, see, it's not linked correctly. That's why.
Okay,
Sorry,
all right.
All right.
That's fair.
take you back to where we were.
I have failed you.
No, you haven't. And here we go.
But to hear my wife scream is awesome. No, I'm kidding. This, there's those clinching moments. This was a clinching moment. But we get east and we start heading south again to try to give chase to this thing. But again, it surrounded itself with all this dirt. You can't even see the tornado. And by this time, there was a second tornado to the left. And so now I'm having to figure out which tornado I want to dance with, not the one that's local. And we were getting some big hail, golf ball size hail out of this thing. And this thing was long lived. It was on the ground for, almost an hour, traveled across. We'll see the damage path here in just a second. But here's, it finally unveiled itself briefly. And my wife took this picture. I was scared to death because I'd already had power lines come down and they were the small kind. This is a much higher set of power lines on the parallel of this road. Don't want those coming down on top of me because that would hurt bad. Actually, this tornado crossed the highway that we're on several miles further to the south, and we could see where it knocked the poles over. South Plains Electric Co-op, which is the power provider for that area, they were up for weeks trying to replace everything that this thing did. Yeah, there's the poles later. We actually went into post and got gas and had to come back around. And by that time, I think something like 6 inches of rain had been dumped on Lynn County. The good news is all of it ended up at Lake Allen Henry in our water supply, but you should have seen the torrent and river of water that was moving out of Lynn County into Garza County to get down into that lake. It was a mess. In fact, I was in the Yukon high off the ground, water was starting to come up to the top of the wheels and the fenders. And I'm like, what am I doing? Turn around, don't drown, DG. I was like, this isn't worth it. And so, I see nothing but a lake ahead of me. And so I'm like, well, at least I know where the road is behind me. So I turned around and we went back. But yeah, it dumped a copious amount of rain. So here's the radar picture. The black dot in the middle is the radar out by the airport. And down here, this is Lynn County. So this is Lynn County to the south, where these two roads intersect. That's Tahoka. And you see where the circulation, that hook barely misses town. This was impressive on radar. And I said, we weren't expecting tornadoes that day, but look at that green line on the west side. That's the outflow boundary. This provided us the next day with another round. This acted as the focus for severe weather the next day, further up in the panhandle. But look at all that red and orange on the Doppler. That's all rain that just fell in eastern Lynn, western Garza, several inches within, a short period. It was a mess. But yeah, you can easily see the tornadic circulation, even though the Doppler is looking in the middle part of the storm. That rotation was still pronounced that in the mid and upper levels of the storm, that circulation was evident even on the radar. But yeah, this was a monster. So here's a close-up. On the left, we're looking at the energy return. So this is kind of an indication of hail. So the white is 65 dBz. That's pretty high. Softballs are bigger. Here's Tahoka. Here's the circulation, the tornadic circulation, big hook echo. And then on the right side, we're actually measuring the velocity. And the velocity product is showing, what is this? I don't know if that's miles per hour or knots. I think it's knots. Okay, so we're showing 50 to 60, the pink right there. So 60 knot winds. I don't know what the math is on that. Probably over 120 miles an hour. So, but it was really intense. Here's the damage path. It was 1.2 miles wide at its widest point when we were watching it as it crossed the highway ahead of us. And I wished I could show you that video, because what was astounding to me was the traffic that was coming from that tornado. I was like, there was a guy towing his boat behind in the trailer. I was like, how in the heck did you get through there? School buses. I'm just like, oh my God, this is nuts. But yeah, there was people on 380 coming through that storm, had no idea, because you couldn't tell it was a tornado. It just looked like a dust storm, a haboob, right? But yeah, it started up here near the top, crossed 87, barely missed Tahoka, and then did this curlicue at the end. And then there was a second tornado, I think, that was further down that crossed into Garza County. And here's just fortunately, this is, monster tornado, 1.2 miles wide, and it's only rated an F2, an EF2. What? Because this is all it destroyed. It knocked some power lines down, broke some telephone poles. Okay. Blew up a trailer, knocked a tree over, did some house damage. Again, on the Fujita scale, they're looking for the worst damage possible, and this is the worst they could find. And so that's what it was rated. So you can't look at a tornado and say, oh, that's an F5, definitely. It's based on damage. Some of the skinniest, most nonchalant looking tornadoes are probably the worst, and some of the nastiest, ugliest, fattest, obese things I've ever seen, nothing. So, yeah, it was rated an EF2. Peak wind, 120 miles an hour. But it was a beast. Couldn't see it. So this was the survey results after. So the next day, or actually later in the week, this was a couple of days later, we were up in the Panhandle, and I was in Plainview watching this storm. I was like going to the airport in Plainview. Unlike the airport in Lubbock, there's no TSA out there. They don't stop you. And it's nice and level. It's level and open, and I can see in all directions. In fact, those pictures of the Hummer I took early, that's where we were, was at the Plainview Airport. So because it's nice and open and I've got a clear view in all directions. So I usually go up there. If I have to wait, I'll wait at the Plainview Airport. So we're watching these storms develop, and they quickly develop. I mean, this thing explodes. We're up near, I think this was halfway is the town in the distance. We're going to the west. And what catches your attention right away? My mentor, Al Harden, who I love dearly, and he taught me a lot of this stuff. He had a very scientific name for that kind of a cloud, a hangy down thing. There's a hangy down thing. And and this is a copyright DG picture, and you know why? Because I've got the antenna right in the middle of it. Jeez. Here we are closer watching it, and I wished I could play the video because I actually had a time lapse of this, and that thing was spinning quite rapidly. So yeah, we had an area of interest. That's what we call this. Yeah, Ron, we've got an area of interest here. And that's kind of DG speak for, yeah, we don't know what's going on, but we think this is where we're supposed to be. And we watched it as it developed, and it started taking off to the north really quick. That's probably as nasty as it got. Again, antenna in the picture, let's see. So that went away, and it quickly recycles, and you can just barely see above the horizon there. It's starting to cycle up again. So we didn't get a tornado out of the first incident. And here we are looking at the second spin up off in the distance. And so now I'm trying to get over there to get a closer look on it. And we finally get there and here it is in the foreground. And again, it's spinning again. Yep, we've still got rotation. So whenever we have a cyclic storm, that's bad news because these things can, once they finally get their act together, they can put down several tornadoes, one after the other. And it looked really bad. We finally get up near, I think, Happy. We went through Tulia and then Happy. And yeah, it starts really getting its act together in a hurry. This was probably the worst I got because now it's putting out so much rain, but you can kind of see this little depression here. This bulge, that's the actual wall cloud. And the tornado comes out in the middle of it, but we never saw it because it was rain wrapped. High precipitation event. Everything about that is just rain everywhere. Showed up pretty well on radar. In fact, that's what the Weather Service finally warned on. And by this time, we're up in Amarillo's warning area. So the Weather Service out of Amarillo is issuing the warnings on this. But it was really nasty. Here it is over. This was over Happy, I think. We're on the interstate. Just really impressive. And then it starts falling apart and getting very ragged looking. You get these little cloud tags and it's like, I'm looking at this going, I don't know what's going on, but I don't like it. And so we stay with it as long as we can. But since we're so far up north in the Panhandle, it's like, I'm not going to chase this into Oklahoma. Lubbock is my hometown. I'm going to go back to, I want to go home. So we did, but yeah, just look at the contrast. This kind of looks like that picture I showed you, the supercell, the striations, rain, just heavy rain. Yes, if you see storm coming like this and it's got a jade green hue to it, take shelter, big hail. It's true. I've seen storms that have so much ice, the light going through it is actually filtered to a green color. It has a sick greenish hue. And I've learned that that's usually bad hail. This had a lot of green in it. It was quite. So talking about what other drivers do when they panic. So big hail, this storm had a lot of big hail to it. So we're driving south on the interstate. And what do you notice that the other people are doing? They're stopped under the overpass. Okay, this is a big no-no. Imagine if you're an 18-wheeler doing 80. DG does 80, why wouldn't a truck driver? And it's at night. And you come upon this, this is the scary scenario. Yeah, these people, this is bad. This is not good. Fortunately, I'm going southbound. This was all the northbound traffic. Now, what if Happy got hit? And this happened earlier. I actually was at the Happy tornado that happened in, when was that? 90, 99, 98. They actually requested aid from the other towns. And so now imagine fire trucks and ambulances trying to get from Tulia up to Happy. What are they going to come across? They're going to come across this mess and they can't get to where they need to because people are blocking the interstate. I don't know about you, but when I took defensive driving or driver's ed, you don't stop on the interstate. You pull off onto the shoulder. Okay. So yeah, this was crazy, but people parking under the bridge as if that's going to afford you a whole lot of protection. And this is what I mean when I say the most dangerous thing I face when I'm out storm chasing isn't the weather, it's other drivers. This is crazy. Yeah, this is nuts. And I was honking and probably flipping them off as I was driving. Anyway, yeah, I mean, see how much the traffic's back. And then imagine the people are like, what's going on? I want to get to where I got to go. So yeah, this was crazy. So, okay. My time's about up. In fact, my time is up. So at the end of that week, as if I didn't have enough fun that whole week chasing big tornadoes near Tahoka and up in the Panhandle and doing all that stuff, Friday, May 10th, 2019 is a day that will live in my infamy. Was in my backyard. It was a day like today. It was cold and it was May. Okay. So what killed the rest of our severe season that year was this cold front that came down, cut off the moisture at the surface and cooled everything off. And that Friday, May 10th, was cold and gray, kind of like today. It felt like fall weather. And it was raining, light rain all day long, just all day. It was just raining, not heavy, but just rain like we had last week. And so I'm out on my porch. This is my backyard, my porch. And I was home early. I was getting ready to fix hamburger helper or something for dinner, right? And I'm like, because I'm a weather geek, I'm like, wonder what the weather's doing. I'm going to run outside right quick. And so I run out. I'm in my shorts. I don't have my cell phone with me. I'm in a pair of Crocs, and that should give it away right there. Okay. Wet concrete, and what happens to DG? I slip and I break my knee. I felt it pop before I even hit the ground. And I'm out. Boom, I'm out. I was hospitalized. Unfortunately, my wife got home. I'm screaming because I can't move. It hurts so bad. But yeah, so here's the fracture right here. My doctor, my orthopedist said, you broke your knee in the worst way possible. You know, if you're going to do it right. Right. So yeah, I had a lot of hardware. You can see the staples that they had to suture me up, and I was off my leg for the next 6 months. This put me, I mean, I was in a bad place. I was in the ICU for 3 weeks. And yeah, I remember the rest of 2019 quite well, not because of my chasing exploits, but because of the hospitalization I required the rest of the year. And fortunately, I was back in pretty good condition. I was able to walk by the time 2020 happened. And then we all had our fun with health issues in the year 2020. So yeah, this was my story. So yeah, that July 4th, I'm chasing. I said, Ron, I'm ready to go. Just let me go. I've got the wheelchair. I've got my binoculars. I got my walkie-talkie. I've got my highly technological wind instrument there at the ready to measure the winds. So yeah, this was a good laugh.
That is technically a weather related.
Yes, it was. So I slipped on my back porch. You know, if the weather's going to kill me, it's not going to take me out with a tornado or large hail or lightning. It's going to get me. And I'm here to tell you, wet concrete is my kryptonite. I'm terrified of it. And it paralyzed me. I mean, I still walk with a hobble today, but yeah, that ended my storm season that year. And then we had COVID the next year, and it's been fairly quiet. This year we had a pretty active season. Matador got hit. You know, I was not out for that one. I only went out once this year. Yes, Perryton up in the Panhandle got hit first, and then like a week later, yeah. Yeah, it was, and that went due south, you know, talk about directions. That summer, I was able to interview Barry Corbin, one of my movie heroes. He went to Texas Tech. And then he told me about how he convinced G.W. Bailey to skip going to Tech Law School and to pursue acting instead. And so a month later, I got to interview G.W. Bailey. But you'll notice between my legs is the crutch. I was still on crutches at that point. But yeah, I got to interview G.W. Bailey that year. So, you know, all's well that ends well. But it was fun. 2019 was my last big chase. And that's not to say we haven't had bad weather since. We have. One of the things that's really changed how we do business is social media. So spotting isn't really as big a deal as it used to be, because now everybody can take a picture, upload it to social media. The Weather Service can get that information, the TV station. You know, Ron Roberts, hey, send us a picture of your hail. And all he'll do on the 10 o'clock news that night is just show everybody's hail pictures. So, you know, a couple of dozen people out trying to chase the storms versus society who lives out there. You know, do we still need spotters? Yes, but the public reports are now kind of taking that role over. And Ron, believe it or not, and it took me the longest time to believe this, television isn't what it used to be. I would think, you know, television, I always grew up with radio and TV being the primary warning method. The media was always radio and television. And I believed in that. That's what got me into the business and why I still do this today. But when Ron was telling me, no, I've got more viewers on Facebook than I do on television, I'm like, what? Are you serious? He's like, yeah. And it makes sense because people can interact, you know, and he actually has he's got 4 times a larger audience on Facebook than he ever did in the glory days on KAMC-28 television. It's fascinating. And so, you know, I can remember when Desperate Housewives would be on and he would interrupt. Oh my God, you would think that we had, you know, killed the Pope or something. The NBA finals would be on and ABC was covering it, you know, and he'd do a break in. And folks don't realize, you know, broadcasters have a responsibility because they get that license. We have a license by the FCC and we're supposed to operate in the public interest. And your safety is kind of foremost in that category. So people would call and complain, but on Facebook, they're not preempting anything. People actually sign up to watch that. And so, yeah, social media is a huge game changer now. I don't use a two-way radio to talk to the Weather Service. Instead, the National Weather Service has NWS chat. It's a chat group. So I can report directly to the Weather Service through chat. We have to have internet in the car. I was thinking of bringing all this equipment. I thought, no, I'd bore you to tears because, ancient technology. But now what do I use for chasing? This. So I'll talk to Ron, I'll have my headset on and I can talk to him on the phone, be live with Ron at the TV studio. And then I have an iPad on a tripod and I use the camera, and we have an app that streams it directly through the cell service back to the TV studio. It's fancy. Don't even have to have a laptop computer anymore. So yeah, compared to the old days when it's like, which direction you think we should go? I don't know. Let's go this way. I used to have a rule is whoever was riding with me in the car, I'd say, it doesn't matter which way we start out in, because by the time the night and the chase is over, we're going to be on the opposite side of the South Plains from where we started anyway. Because Ron's like, okay, I want you to go in Littlefield, go up to Littlefield. And as it starts, and then I'll be down near Sweetwater, Snyder. It's nuts. So, well, that's my presentation. Questions, comments, complaints? Yes, sir.
Is there a phenomenon that you can discuss where a thunderstorm suddenly falls apart?
Yes.
And you have extremely fast winds straight down.
Yes. So we call that a downburst, and they come in two varieties, dry or wet, if there's rain with it. So a lot of times what happens, especially depending on the time of year, you can get thunderstorms form, but they'll start to collapse and the rain evaporates on the way down. Well, that cools the air and makes it heavier and colder. And so the air comes down even faster. And that's what we call a dry macroburst or a dry downburst. So you get the winds coming down. Well, it can't go into the earth. So what's it going to do? It's going to spread out when it hits the surface. And you can easily get straight line winds of 60, 80 miles an hour out of a collapsing thunderstorm. Oh, very much so. Like I said, people don't understand what 60 and 80 mile an hour winds can do to things. In some cases, worse damage than an F1, F2 tornado. And we call it straight line wind damage because that's how you determine, is it wind damage, straight line winds versus a tornado. A tornado is going to throw debris in all directions. Whereas if it's straight line winds, you can look at the damage and go, I wonder where these shingles came from. Well, let's look back upwind. Oh, that house there. Straight from where the source is. So all the debris is straight downwind, and that's what straight line winds are. But like I say, most of my neighbors, oh no, it had to be a tornado. It sounded like a freight train, My dad worked for the railroad, grew up around trains, still love trains. I have not heard a tornado sound like a freight train yet. Usually because the hail hitting the window of the car is much louder than the wind is, but it's a good question. Any other question? What about Zoom? You guys on Zoom still awake? They've already left. They left at 7. It's 8 minutes past, and I don't want to keep y'all good folks here unless you really want to. But I got a million stories and I could go for hours, but we've already been here long enough. What else you want to know? Well, thank you, sir. I appreciate y'all coming. So yeah, if you get a chance, if you visit the science spec, so the Weather Service has moved from the airport to the South Loop. It was the old Time DC building, if you're old enough to remember what that building was back in the day. The Science Spectrum is there, and the Weather Service, that's where their offices are located. And if you haven't, I highly recommend getting a tour of the Weather Service. They're nice folks. Is there a survey that they fill out for this? Oh, okay. Put in a good word, if you would. I have fun doing this. Yeah, exactly. And keep it here. We'll keep you advised, as Ron says. And hopefully we'll see you out on the road somewhere. But be safe. So the rest of this week,